We're going to talk about relationships between categorical variables. Who can tell me something about categorical numbers? Don't say categorical numbers fit in categories, please. That you can't say. They're descriptive. That's right. They're descriptive. Good. Yeah. So categorical values are generally totaled as a percent of the whole or percent of the group, of a group. When we're talking about percent of a group, these are called conditional distributions. And I'm convinced the very best way to go about showing you this is to do one of the problems from today's assignment. So let's look at problem 4.25. It's on page 298. And it is smoking by students and their parents. And so we have some data. I'm going to put it into a table. We have students who smoke, students who don't smoke, non-smoking students, and we have smoking students. What I'm making here is called a two-way table. I think it's entirely possible that you've seen some version of this somewhere along the line in your past, but it's compared to what we learned the other day, this is completely different and quite easier, I think. So here we're talking about students. Up here we're going to go parents. Parents where neither smokes. One smokes. Both smoke. I'm going to leave a little room there on the end. And the problem gives us some data. We have 1,168 non-smoking students where neither of their parents smoke, 1,823 where one parent smokes but the student doesn't, and 1,380 where both parents smoke and the student is non-smoking. For smoking students, 188 where their parents don't smoke, 416 where one parent smokes, and 400 where both parents smoke. So this is the data given in the problem. What we want to do is we want to get what's called our marginal distributions. So that's going to be our totals. Total for the columns, also total for the rows. I actually have those numbers, so you can cheat off me if you'd like. This is 1356. This is 2239. So what I'm doing is I'm adding the 1168 and the 188, the 1823 and the 416. So these are the total of the columns. 1780. Over here, this is a total of the top row, 4371. Excuse me, and 1004. This little box, I call it the grand total. It's the total of all of the columns, and or, it should be the same, the total of the rows here. So this would be 5,375. So what I mean by that is totaling these guys, this is that total here, same thing. All right, so you can kind of double check your numbers if you wanted to. And we call these marginal distributions. Alright, so let's see what the question asks of us. A asks us, how many students are described in the two-way table? Well, once you've made the table, oftentimes the answers are pretty straightforward. So how many students are we talking about here? Yeah, 5,375. Okay. B, what percent of these students smoke? How am I going to figure out what percent of the students smoke? Courtney? Yeah. The grand total, yeah, right. So the total of the smoking students, 1,004, dividing by the 5,375, and I get that that's about 18.7%, give or take a little bit. These are the 18.7% smoke. And C asks us for, let's see, how does it ask us? It says, give the marginal distribution of parents' smoking behavior both in counts and in percents. Counts is important. That's just the number. So what we're looking at here is the parents' information in relation to the total. So for the neither smokes, I've got 1,356 is my count, but if I divide that by the 5,375, that gives me the percent, where the percent of students where neither parent smokes is 25.2%. So this is the count. Let's do this. Let's say counts and then we've got the percent. So the next one's going to be 2239 divided by 5375. 2239 being the count, and in this case it's where one parent smokes, and that percent is about 41.7%. I hope these numbers are wrong, honestly, but. And the last one is 1780 divided by the 5375. So again, there's your count. This is where your two parents smoke, and that's about 33.1%. Gosh, I haven't even graphed anything yet. Yeah, this is a new day, right? I could use a 4-function calculator for this one. All right. D asks for the conditional distributions. I've got to go to the next page for that, but I'm going to keep this handy. So is everybody with me and ready? Yeah. Okay. So on the conditional distributions, I'm basically going to sort of remake the table. This is D. Now, conditional distributions can be done a couple of different ways. It says calculate 3 conditional distributions of students' smoking behavior, one for each of the 3 parental smoking categories. Describe the relationship. So I've got no smokers and smokers. These are the students. And I've got the parents where neither smokes, one smokes, and 2 smoke. So I'm just kind of recopying that. And what I'm going to be looking at here is the column. So in this column, I want to calculate the percentage of non-smoking students in relation to neither parent smoking. So that's going to be 1168 divided by 1356, which is about 86%. And if we're calculating the column here, if this is 86%, what percent of the students smoke where neither parent smokes? Yeah, 14%, right, Sydney? Yeah, I agree. So this is going to be 14%. It's 100 minus the 86, or 188 divided by the 1356. Okay. So the next one's going to be 1823 divided by the total that we had in that column earlier, which is 2239, which is going to give us 81%, and 100 minus 81%, 19% smoke when one parent smokes, or 416 divided by 2239. In the last column, we've got 1,380 students that don't smoke out of 1,780 total in that category. So we've got 78% where both parents smoke, but the child doesn't. And so that must be 22% where the child does smoke, which would be 400 divided by 1780. these are called conditional distributions. It's conditional because in this case it's conditioned on what the parents' habits are. But you could also do a conditional distribution where it would be rows, and it would be conditioned on what the students' habits are. You know, so it can go both ways. It depends on what the question's asking as to which way you would go, but it can go either way. So the next part of this is just we want to make a sort of a conclusion about the numbers that we see here. What I'm seeing is that whether the parent smokes or not does seem to have some impact on whether their child smokes or not. So the more a child is more likely to smoke if their parents smoke. So we go from 14 to 19 to 22%, depending on one or two parents smoking. That would be probably something that I would say, but you could also kind of turn that around and say, if neither parent smokes, then the child is less likely to be a smoker. You could kind of flip it that way too and say that. So we want to kind of analyze that data in some way or another. And that's conditional distributions. So I hope that is a nice reprise from the logs that we did the other day.